Okay, so in this video we're going to explore how to solve one-step equations. A couple of vocabulary words today. Inverse operations, we are looking at operations that undo each other. So we have four basic operations: multiplication, division, addition, and subtraction. So if we look at our two operations that we want to make zero, if we have addition, the inverse operation of addition would be subtraction, because we want to make that item zero. And then vice versa, subtraction would be addition. So those two operations work hand in hand to make zero. And to make one, multiplication, the inverse operation of multiplication would be division, and vice versa, division's inverse operation would be multiplication. Our second vocabulary word, equivalent equations. Equations that have the same solutions. So for example, if we have the equation x plus 2, and we use our inverse operation so we know that x is being added by 2, we can produce an equivalent equation if we use the inverse operation of addition by 2. So if we subtract 2 from the left side of the equation and the right side of the equation, we produce two equivalent equations. So the bottom line, x plus 2 minus 2 equals 17 minus 2, is the same thing as x plus 2 equals 17. So we sort of just talked about this, the addition property of equality. If we add the same number to each side of an equation, it produces an equivalent equation. So if we use the subtraction property of equality, subtracting the same number to each side of the equation produces an equivalent equation as well. So taking a look at the first example where we have to solve y plus 3 equals 10, this is considered a one-step equation because it literally requires just one step. Now analyzing our equation, what's going on, we have the y that's being added by 3. So the inverse operation, because we want to zero out the 3, so we have to use the inverse operation of addition and subtract the 3 from both sides. Now the both sides I refer to is the left side of the equation and the right side of the equation, with the equal sign as our divider. So we subtract 3 on one side and subtract 3 on the other side, and we're left with a y plus 0 equals 7. So if you notice, 3 minus 3 equals 0, so our remaining equation is y plus 0 equals 7. We don't have to write down that 0. We just know that if we use the inverse operations of addition, it'll zero out that quantity, so we don't even have to write that. So right now, our answer is y equals 7. Now to check to see if that's right, we take our value for y, and we substitute that back in to our equation. So here's our original equation. We're going to check to see if that's right. We substitute in the y equals 7, 7 plus 3 equals 10, and then 10 does equal 10, so that works out. Now our second example, we have x minus 7 tenths equals 1/2, and we're solving the equation. So when we solve the equation, we're trying to find the value of x in this specific situation. So we notice that what's being done to x is we're actually taking away 7 tenths from it. So the inverse operation to zero this out would be to add the 7 tenths to both sides. So if we add 7 tenths to the left side and add 7 tenths to the right side, we're left with an x plus 0 equals, well, let's take a look at how we actually add 1/2 and 7 tenths together on the side here. So 1/2 plus 7 tenths, how do we do this without a calculator? In order to add fractions, our denominators have to be the same value. So the least common denominator between 2 and 10 would be a 10. So I'm going to multiply the numerator and denominator by 5 so that I have 5 over 10, because that's the same thing as 1/2. So now that I have 5 tenths plus 7 tenths, I can add the two fractions together because the denominators are the same. So we just add the numerator, so we get 12 over 10, and we can write that back into our equation. So we know that we don't have to write the 0 down. We just have our value of x equals 12 over 10. If you ever have your solution end up being a fraction, make sure you always reduce it. So 12 over 10 can be reduced down to 6 over 5. We just divided 12 by 2 to get 6 and 10 by 2 to get 5. So our final answer is x equals 6/5. So whenever we're solving our one-step equations, we always think about the inverse operations that's given. So in a situation where we're multiplying, if you multiply each side of an equation, that'll produce an equivalent equation. But you always have to do the same thing on one side to the other. Same thing with division. If you divide both sides by the same non-zero number, it'll produce an equivalent equation as well. So math and algebra has to make sense where you balance both sides of the equation so that you're not changing the value of the previous equation. Example number 3, we're going to solve the equation 8x equals 56. So we're solving for the value of x. A lot of people get tripped up by when they see 8x, they don't really see an operation going on, but if there's always a number or a coefficient in front of a variable, the operation is multiplication. So we're multiplying 8 and x together. So in order for us to solve this equation, we must use the inverse operation of multiplication. So we got to make sure that we can get this turned into 1. So in order for us to make this into 1, we have to divide both sides by 8. So we know that 8 divided by 8 is equal to 1 and not 0. So when you hear like people cancel things out, it's because 1 is an imaginary, I guess, number that's in front of the x. It exists, but you don't have to write it. So we can write, just for the sake of understanding and see how it works, 8 over 8 is, or 8 divided by 8 is 1. Drop down the x equals 7. And we don't have to write that 1 down. We can just write down x equals 7 as our final solution. So 1x and just x is the same exact thing. Example number 4, we're still solving equations. So in a, we have to solve for the value of a in this specific equation. So right now we have a divided by 5, and we got to make sure that we can get this into 1. That's what we want to, that's our goal here. So in order for us to make this 1, we have to use the inverse operation of what's being done to a. So a is being divided by 5. So in order for it to make it 1, for us to make it 1, we have to multiply both sides by 5. So we have 5a over 5 equals 60. And we know that when we cancel that out, it's not canceling it, but it's making sure that we can put that into a 1. So we'd write down 1a equals 60. And again, we don't have to write the 1 down. Instead, we can just write down a equals 60 as our final answer. In the second example, where we have 3/5 times t equals 6, and we're trying to solve for the value of t. And now, when we have a coefficient that's a fraction, this is actually a twofer. We can do two operations, two inverse operations at one time in order for us to make this 1. So right now, if you really look at it, 3 is being multiplied to t while the whole entire quantity is being divided by 5. So the best way for us to make this quantity 1 is to multiply by the reciprocal. So we're still going to make this 1. And if we multiply both sides by the reciprocal of 3/5, the reciprocal where you flip the 3 and the 5's position. So now the numerator would be 5 and the denominator would be 3. And then you do that to both sides. So when you multiply across, 3 times 5 is 15, so we write that up top. 3 times 5 is 15 again, and we still have the t from the original equation, equals 30 over 3. So we simplify. We know that 15 divided by 15 is just going to be 1, so we write that out as 1t, and then 30 divided by 3 equals 10. And again, we don't have to write the 1 down. We can just write down t equals 10. Alright, thanks for watching. Make sure you guys write down any questions that you have. If something didn't make sense or if you need more practice, make sure you do the You Try Nows below and come to class ready to go.